if anyone has questions on any of the previous homework or the current homework, make sure you post those questions in the chat. Okay, so we were talking about how to control the sequence of a program last time by using if statements. I think I need to change the label on this too, because we didn't actually go over chapter 4 because we're not doing flowcharting in this class. Here we go. Selection structure. That's what we were looking at. All right, asking about 4.4 hands-on activity. Let me double check that. I think I might have changed that. Let me see. Okay, so I changed the name here to doing it in JavaScript. So let's pull that up here. Make sure there's no issues with writing that in JavaScript. And if you finished it in pseudocode, it shouldn't be too hard to convert it to JavaScript, but if you need more time, just let me know. It's no problem. Oh, good. Well, that makes it easy. Yeah, the JavaScript is what I need. Thank you. Okay. Should change this here while I'm here. And while I'm thinking about it, I should go ahead and change this one.
I didn't print out.
This is the one where it was echoey the whole time because no one warned me. Okay, I got all that straightened out though. All right, so we left off. I think I just started to talk about things and went off script on the PowerPoint, so I think this demo will be a better outline of what's going on. Okay, so last time we looked at how to structure an if statement and what it's for. And now I'm remembering I had that diagram. I would have put it in this class, so maybe I lost it. Oh well, it wasn't that impressive. Okay. I feel like being able to see a visual representation of what's happening makes this a lot easier to understand. So we're going to move on from the if statement pseudocode. Here we go. All right, so we haven't talked about the next structure, I think. Let's see. We were just looking at ifs so that we can understand, you know, how to use it. Okay, it creates a branch in your program that can run optional code, and it runs that code if the value here evaluates to true, and it skips over if it evaluates to false. So last time we saw, we can see this expression evaluates to true. It's just a variable, so we have to see what is stored in there. It's a 7. Okay, do you guys remember why 7 evaluates to true? The other thing we talked about was formatting your if statements in code blocks. So we can see that example here. So if you do not have curly braces after your if statement, it's only going to look at the next line. If you do have curly braces, you can attach multiple lines of code to your if statement. So here we have the curly braces. We use those when we want to insert a block of code. All right, and you'll see those return for some of the other structures. Okay, so I am going to adjust this. Also, if I'm not talking loud enough, let me know. And let's take a look at the next part, which is creating a structure that forces the program to choose between two paths. Right? You'll provide one set of results for true and another for false, and then the program will continue, and they have that drawn here. So what they aren't showing here is, you know, here at the top is the start of the program when you hit run.
Now let's look at the same.
Whoops. Lost my place. All right. All right, where did that go? All right. So how would this look in the code? All right, well, let's take a look here. Let's see if you guys can remember what I'm doing here. So I'm just dividing these examples up into separate JavaScript files so that I can just switch between them. Here, if I want to run the code in if.js, I can include a file path to that file in a script tag, and then you would place the script at the bottom of the body. Okay, so for this, there are different reasons you would put it in different places and things, but just to make sure it works in our class, you want to make sure the script is at the end of your body, because we'll be using it to manipulate elements on a web page, which need to be loaded before they can be accessed. So the page should load all of the elements which are contained in the body, and then it'll load the script. That's why that is the way it is. All right, and since I have it set to if else.js, it won't run any code in here. It'll just run the code in if else.js. Also, you're not limited to one of these. You can have as many scripts in here as you want, and they can work together. If you plan on taking object-oriented programming in the future, that's a course where we'll talk about something called the separation of concerns, where you try to divide every task in your program into one piece that you can change or take out, and it's independent of any other piece. So one thing that you can do by using these script tags is create more modular code. So, I could have a JavaScript file that is for finding all the prime numbers up to 1,000,000 or something, and I can just write that code in here, and then I can copy that and reuse it in any other program. All right. For now, you guys are just writing. The programs we're writing in here are fairly small, so we just throw it all in one place because you're just trying to learn how to program. We're not focusing on the best way to develop software yet. Okay, because it's kind of hard to understand how to apply this before you even know how to use it. Okay. Anyway, we're gonna have to put some code in here. So I'm gonna do let number equal 100. All right, and then I could do an if statement. If number greater than 50, console.log, and I just like to output to the console. There's a lot less overhead than document.write, just for testing output. When you want to manipulate elements on the page, obviously you'll have to reference those, and the console can be used as a debugging tool. Hey Miles, I think I got some emails from some of you, but I haven't had time to get to them. I'll get to them by 3 for sure. 3 is when my last class ends. So if you're waiting for some answer, that's when you should expect it. Okay. We'll put number is greater than 50. All right. Now remind me if we have already talked about string concatenation in this class. Oh, remember, don't put a semicolon at the end of your if statement, because it'll consider that basically as the statement that it will run if true. So, okay. Yeah, we've definitely done string concatenation. Okay. So let's say we want the message to show if the number is greater than 50, or tell us if it's less than 50, or I guess less than or equal to 50. So that way we can include every possible value. And if you guys remember back to math class when you were introduced to greater than and less than signs, you don't really encounter them all that often in day-to-day life. So if you have a problem identifying those or understanding the difference between any of the comparison operators, right? So we have double equals is equals, we have less than, greater than, and then the tricky one, especially in programming, because you have to be very specific, is less than or equal to and greater than or equal to. And you should know the difference between less than and less than or equal to. Okay. So if this is only true if the number is greater than 50, what possible values would make this true? Would 100? Yeah, that one's pretty easy because we know 100 is greater than 50. 51, that's greater than 50. What about 50? Okay. If you put this comparison operator here, greater than, then that means do not include 50, but every number with a higher value than 50, right? Now if I put an equal sign, now I'm including 50 in that calculation, okay? A lot of bad things can happen if you don't use the right comparison operator. And by a lot of bad things, I mean just extra work for trying to figure out why it's not working. For now, and then if you get a job, I get this. It must be at least every other semester. I have someone who's gotten a job after doing the program, and they tell me horror stories of where even the most senior developer will make a mistake and put 1 equal sign instead of 2, which couldn't be farther from each other in what they mean inside the computer. So the problem with it is, okay, if I use the double equals, oops, okay, it's going to tell us that well, ignore the message, but 100 isn't equal to 50. So it's going to run it won't run the code on line 4 because that's part of the if statements checking if it's true, but it will run the line of code after the else. Because it's not true. But let me change the messages here. Let's go. Number is equal to is not. Okay. So 100 is not equal to 50. What happens if we do this? And what is the difference here between using 1 or 2 equal signs? Okay. See what happens. In this case, we actually just get a logic error, which is worse because the program doesn't crash and it doesn't tell us where the problem is. That's because there is no problem. It's doing exactly what we told it to do, which is change the value in 50. I'm sorry, the value in the number variable to 50. Okay, but we're not checking if it's actually equal to 50. So why does it say this? Let's change it to 72. Okay. So 72 is equal to 50. Let's try 10. 10 is equal to 50. So that's obviously wrong. And you know why it's wrong, because we used 1 equal sign instead of 2. But why would that cause it to run the true statement instead of the else? Think about it for a second. It has to do with the code we wrote in here, because remember we looked at a lot of weird things like this keyword of null, this keyword of NaN, which is not a number, keyword of undefined, and we had just some string value and some numeric values, and they acted differently when JavaScript was determining whether they were true or false. Okay, so anyway, if you can't figure it out or you just want me to explain it, we'll go over it. So it might help if we do this. Here's the thing. If you don't understand something that's going on, just try to print it out. That gives you more information to work with. So if I console.log number equals 10, all right, when I say equals, I mean the equals comparison operator, not the equals sign. what is the single equal sign called again? Think about it. This is really important that as you're looking at this and working with it, to call it what it is so that you can separate the two. All right. So here's our output of this console.log. Okay, and we know this should be false because 100 is not equal to 10, but it's printing out the result of this comparison. So now we can see this is going to be false. And so we can put console.log the value from this equals, one equal sign is the assignment operator. So we're assigning the value of 10 into number. What does that be? What would that become, true or false? Or maybe something else? Let's see. All right. This becomes the number 10. So it just prints out the number 10. Okay. So why would having a 10 in here evaluate to true? In our previous example, we put a 7 in there, I think. We put a 7 as x. Okay. Then we did if x is true. Oops, I can't run this right now. And so then that evaluates to true. I guess we can just do it right in here. Let's do if 10 and let's comment this out. So if 10 evaluates to true, it should print this first message. Excuse me. All right, if it's false, it should print this message. All right, so 10 evaluates to true. And let's check 0, because I think we determined 0 will evaluate to false. Try negative numbers. That evaluates to true. You know, it might be easier to see if I just put true. And false in here. Then you can just pop in the values and see. Okay, -1 is true. So any, you know, negative 0.07007, is that going to be true or false? True. Okay. So every number should evaluate to true except for 0, at least in JavaScript. And there's actually a reason, or this actually makes numbers good for, basically you can use a number to calculate how closely two things are matched by assigning a value that represents how different they are. Okay, so that's a mouthful, but think about alphabetizing. Right? If you're alphabetizing, let's say, a list of names, think about as a person, what are the steps that you go through? Let's say you have 3, let's say it's an easy job. You have 3 names you want to alphabetize. All right. As soon as this loads, we'll say, I might not have internet right now. oh well. We can move to Notepad for now. Oh, now it's going to work. Okay. So let's say we wanted to alphabetize the following names: Jim, Sally, Sarah. All right. So as a person, what steps, and this is a good way to just think of how to write a program for simpler things that you can do as a human. There are things that a computer can do that we can't even conceive of, which is scary in some ways. Anyway, we want to alphabetize these names. So what are you going to do? You're going to look at the first name, okay? You can actually just pretend you're coming up with a list of directions that someone else is going to have to read to then use to alphabetize these names. So you got to be specific, right? So this is kind of like writing pseudocode, honestly. But for these small programs, you can just think about it. So look at the first name, all right, and you need to compare it to all other names, all right? So let's say I want to compare it to the first name here. How should we compare the two? Well, in alphabetization, you look at the first character. So we have a J and an S, all right? What if the person has no idea the order of the characters in the alphabet? Okay, let's say they only know how to count. They don't know the letters. You could give them a chart that assigns a value to each letter. So we can say A is 1 and Z is 26, all right? And we can say, you know, if the first letter here has a higher value than the first letter here, then this is said to go, if this one has the higher value, J, if J has a higher value than S, well, wait, J would have a lower value. So if this first letter has a lower value like it does, then we don't need to move it because it's already before this one. All right, and so to represent that, we would say when comparing J and S, we might take the value of J and subtract the value of S. If the number is negative, J is before S. If the number is positive, the letter goes after. And then look at these last two names here. So we would determine Jim is before Sally and Jim is before Sarah. So we're done with Jim. All right. Next, we would look at Sally. Okay. She's already been compared to Jim, so we can skip that. But we need to compare Sally and Sarah. Okay, so the first letter, right, we check the value. Well, they actually have the first same letter, so that's going to evaluate to 0. And we can use that value to mean there's a match. Okay, if there's a match, we need to look at the next letter. Well, that one's also the same, so we need to move on to the third letter. Now here it's different, and so we would use the difference in value between the third letter of each name to determine the order. Okay, so I guess by accident I just wrote these names in alphabetical order, so we got lucky. All right, anyway, all of that to say that's why 0 is true, and that way, you know, if I compare two words in a computer, two strings, if it's 0, then it knows they're equal. Okay, if every character evaluates to 0. If not, they find the first character that doesn't evaluate to 0, and then they can move they being the computer can move the value before or after the one it's being compared to. All right. Moving on. So, I wonder if I mentioned enough about if-else. Anyway, the picture here. So, one really important thing about if-else statements is you'll never get both results. So, this program can never print true and false because they are on different paths. And so the program starts, it can only choose one of these paths, and then it will continue on. So you can't have both. Which, I'm describing it like it's a problem, but this is very useful when in situations where you need to be specific about whether something is true or false, or do different things if something's true or false. If something needs to be done differently, if one value is true, then you just need an if statement. But if you really need to have specific code that evaluates if the expression is false, you need both. Okay. And remember, as I'm going through this, if I'm going too fast or you're confused, just say something in the chat. Just say, can you show me another example or something? All right. All right. Now we can talk about nesting our if statements. So, making one decision at a time in a program doesn't give you a lot of control. And honestly, most problems are going to involve so many variables that you may need to nest your selection structures. And unfortunately, in the code, until you're used to seeing it, it's not easy to read. But if you do draw a diagram of the flow of the program, it can help you understand why things aren't working. Okay? Now, so don't create a flow chart, just create a diagram of the flow, right? Okay. So let me think of a situation here. The slides always give really boring situations. Okay, let's say, what's something that's happened recently? Or what have I looked at recently? What was it? Okay, so I was reading this article about using data from social media to sort people's friends into social groups automatically using machine learning. All right. So let's create an nested if-else structure to help group your friends into your various social circles. So for example, on a social network, let's say you have 100 friends. How did you get those friends? Well, you may have worked with some of them at a job. You may have gone to school with some of them. They may be your family. So those would be, examples of different social circles. So let's go in and show that. And we'll create a new file here because I don't want to. What I usually do is just throw all the demo stuff into one, and then, if I ever went back to look at it, I don't even know if I could put it back together to use it. So separating these might be better. Okay, so we want nested if-else.js. All right. make a little note here in case you guys forget. So we want nested if-else.js. All right, so we're going to make a little application that you could, you know, give to your friends to help them determine, or actually, you could get your list of friends and use an app like this to, now this is going to be super simple, so maybe it's a survey to help you ask someone else how to organize their friends. Anyway, we'll need some, we're going to be taking some input and spitting out output, and we'll use some nested selection structures, which before teaching this class, I don't know if I'd ever seen them called selection structures. There's a lot of terminology that's useful for, you know, explaining ideas between people that know the terms. I guess that's any kind of technical language, but at least with the programmers I've worked with, people just call them what they are: if statements, if else. There's other ones we'll look at. Anyway, what is your friend's name? So when I say friends, I mean like if it was a Facebook friend. So if your mom is your Facebook friend, and it says what is your friend's name, it's not saying necessarily that your mom is your friend, just what is her relationship to you, or the relationship between the person that you're testing is not necessarily friend. It's just that's what it's referred to on Facebook. So let's just change it because now I'm confusing myself. We'll just go, what is their name? Okay. And then we need to do Readline. Man, there's so many JavaScript. Readline. No, that's not what I want. It's console.readline. Oops. Should not be this difficult for me to find. Oh well. We'll just trial and error it. So anyway, we'll take in the name of the person, store that in a variable as a string, right? And then let's make sure, let's test this out so I know that it is working. And remember, this is good practice. Test your code one piece at a time as you work on it, or else it'll take you a lot longer to identify errors and fix it. Because if you if you're building a house and you don't do the foundation right, you know, there's no point in building the rest of it. And that kind of follows through in most things. You want to spend a lot of time planning, anything that's important to you anyway, spend time planning before you do it. So we got to print that out. Okay. Readline. Is it just... It's hard to keep straight all the different languages and the... is it just read? Read... Probably just a different name and I'm forgetting. all of these links are to the JavaScript node package console.readline. If anyone knows the code, go ahead and post that. It's so weird. Why can't I remember this? Oh, did it work actually? No. Did I use it in anywhere else? Console.log. So we'll just look at the official documentation. Here we go. Oh, wow. My bad. We've been using prompt. That's right. I don't know if you can read from the console. Yeah, no wonder I couldn't find it. Okay. Because we were using prompt. That's right. Alright. Go back. Alright. I was stuck in C# for a second there. Alright. So yeah. Totally went the wrong direction there. Okay. So now we say, what is their name? Bob. And it prints out Bob. Okay. First part of the class was taking in input and spitting out output, and shouldn't have taken that long, but it's what happens when you don't look at something for multiple days and you look at something similar but different for those days. Okay. Now that we have some info, we can begin asking the user questions about the info. So we want to say, what do we want to know? Let's think of the highest hierarchy. What do you think would be your biggest social circle in, you know what, it doesn't even have to be in social media. What is your largest personal social circle, right? Let's start with maybe we'll just ask some yes or no questions. I think that'll be better. So we'll do let's decide our social circles. Okay, so let's say how are they structured? I'm trying to think of like a hierarchy. So like if you knew someone that you went to school with, you could ask, did you go to high school with me? Or let's try this maybe. Have you ever lived in Mattoon? So we're assuming this person lives in Mattoon because that's where Lakeland College is. So our circle will be people that live in Mattoon, and then from there we can go people that that go to Lakeland College, and then we can determine whether they're a teacher or a fellow student or whatever, advisor, I don't know. All right. Have you ever lived in Mattoon? So we need an if statement now. We'll make it simple. YN. So if answer equals, there, gotta be careful, if answer equals Y, and remember, why are we putting this as a string here? Because when you run this, you're inputting the value into a text box, so it'll be a string when it goes into the computer. Okay, so we need something to happen if the answer is yes, and something to happen if the answer is no, potentially. So we'll say if they answer yes, we need to get more information. So we'll ask them another question here inside of the if statement. It says, have you attended Lakeland College? 3 words. Okay. And then we can say, we can use the same structure again and just nest it right in there. So nesting is taking, taking something and putting it inside something else. So here, I'll actually put another if statement, if else structure. And then you'll quickly see why I mentioned this makes it very hard to read. Okay. And gotta make sure that you keep your indentation right, or else it really will be impossible to read. All right, and then we'll say, we'll do another one because we want to know we'll say, are you a teacher or student? And then in here we can say, don't worry, I'm going to go through this. If it looks like a mess, we'll talk about it. Name is a answer. Okay, and then here this needs to go in here. And then when you have a lot of curly braces, if they start to get stacked up, there's a way you can make sure they're going to the right place here. And that is, you just click on it. So this is the outermost if statement, which needs to contain everything but the else. So if I click it, it highlights it. If I go down, I know here it's highlighted here. It's telling me, okay, this goes all the way to here, so everything inside is included. That can help me determine if I put something in the wrong place. And the worst is when you're moving things around and you remove too many of these curly braces, or you add extra ones in, then it becomes kind of a nightmare. So that's why it's a good idea to maintain your code hygiene by properly indenting. All right, so I'm just going to take out some space here too. So this if is tied into this. I'm sorry, this else is tied to this if. Okay, because this is where this if closes. And if you're going to have an else, it has to go immediately after the if statement closing block, or if you're not using a block, after the line. All right, and since we only want to run both of these if we get this far in the program, and since it's multiple lines, we have to include it in a block. And I've just included blocks everywhere here because I don't know which ones are going to be one line and which ones are going to be multi-line, but I don't want to have to worry about it. So if I just put blocks in everywhere, that won't hurt anything other than my line count. All right, so that's all. I think that's all structured correctly. So once you have it indented correctly, you should be able to look down from the if statement and see the only thing on that vertical position should be the closing block before anything else, if you have it indented correctly. Okay, so we can follow that down for each curly brace. All right, so that one's there, that's good. That one goes there, that's good, and that one goes there. Okay. So these are all nested inside of the ifs. We haven't done any else's yet, but let's see if this works. So this is a program that should be able to detect whether someone is if anyone in the world is a student or teacher at Lakeland in Mattoon. Okay, so let's say Bob. Has he lived in Mattoon? Yes. Has he attended Lakeland College? Yes. Uh-oh. Oh, I forgot to change the text. Wait, did I? Lived in Mattoon. Da, da, da. Oh, I think I put an extra level in there. My bad. Yes. Are you a teacher or a student? I am a student. Bob is a student. Okay. And then let's do some else's here. So, and fix my. Have you attended Lakeland College? So I don't need this. Now this is the fun part, getting rid of these. And then making sure everything's lined up. Alright, so that goes there. That goes there. And that goes there. Okay, all cleaned up, kind of. Nope, it isn't. Because I had an extra else in here, I think. So, see what happens if okay, well, let's start at the bottom here. So we know that one's good. This one's just extra, it looks like. So let's try getting, no. One of these is extra. Okay, I think it's this one. Yeah. All right. This is why I recommend drawing the diagram. A diagram that represents the flow of the program. Not a flow chart, though. Let's make sure it still works. Nope. Line 19, third character. So I think this was the extra thing. All right. Bob. Yes. Attended Lakeland, yes. Teacher. I mean, they could put anything in here. Dinosaur. Because we don't have any data validation. But if every user of any program never made a mistake, this would be foolproof, right? But we can't bank on that. Okay, anyway, I want to do one more branch here so that when we diagram it out, you can see how to do that. Okay, so we need to ask a question if they do not live in Mattoon, a different question. Okay, so all of this will only ever happen. So this block of code right here from this curly brace that's highlighted all the way down to this one, that was highlighted all. This code right here will only ever run or potentially run if their first answer is yes, because that's asking if they're in Mattoon, then we can narrow it down. So in the else, this is where we put if they don't live in Mattoon. All right, and so we can say copy one of these structures, or if you don't want to have to worry about reorganizing things that you copy, typing it is acceptable, but it's more time consuming. Okay, so if they have not lived, if they do not or haven't lived in Mattoon, have not ever lived in Mattoon, we can ask them a different question. Have you been to the moon? If they say yes, we can say, are you human? And then we'll do a case if they are a human and a case if they're not. Why is that purple? Oh, you don't put parentheses after an else statement. You put curly braces. Okay. So we'll say, are you a human? If they say, we'll need this. So if they say yes, we say crisis averted. If they say no, we don't have to check whether they said no, because we're assuming they can only choose yes or no in this case. They can type whatever they want, but in this case we'll assume they could only type yes or no. If they or Y or N, if they type Y, this will happen. If they type anything else, which may be good for this question, because if you can't answer Y or N, there's a good chance you might not be human. So if they say they are not human, we can sound the alarm. Okay, I like how this went from trying to organize people into social circles to detecting who is and isn't an alien. All right. See if I broke everything. All right. What is your name? Zarglax. Whoop. With an A. Have you ever lived in Mattoon? Why, no, I have not. Have you been to the moon? Well, I live there, so yes. Are you human? Well, I guess I'm not. Sound the alarm. Okay. So, we have 1 more minute. So I'm just gonna spend the time before my next class creating the diagram that would represent the paths in this program. And then we'll call it for the day. Alright, so we have the program start. Get out your magnifying glass. There we go. Well, that didn't help. I have a very finicky touchpad on this computer. Okay. So we'll say the program starts. We hit run. And then we have, here we go. I'll just use the manual zoom. Okay, we have a branch. Live in Mattoon. Okay. And then from there we go to the true side is I'll just short it, Lakeland. Alright, and then we can draw a line here. I'll just label this true. This is the true path. And we need, since we have an else statement, we need a false path. Okay. Moon. And that's the false path. Okay. Under Lakeland, we have a couple of paths. One goes to another path. The other one right now kind of just stops. So let's put, we have an octagon. Let's use an octagon. Oh, you have to pay for Pro to get octagons, right? It's too expensive for them to allow me to use an octagon on here. Oh, octagon. Okay. We'll use that as a stop sign. Actually, I guess it's gonna let me write in here. No, it won't. It's not a very good octagon. Oh well, you guys get the idea. Dead end. Okay, so if they say yes to going to Lakeland, we ask, let's see if I'm actually capturing all of the questions here. Have you ever lived, Mattoon, Lakeland College, and then teacher, student. Okay. Actually, this one, there isn't actually a branch at this point, so we don't even need the dead end for this one. Actually, we do. Alright, I'm not going to use that because it's going to throw me off. Let's use a hexagon. That's 2 less sides, but I think you guys will still understand what's going on. So, print teacher or student. Because remember, the way we programmed it, it just does it just prints out whatever you say. All right, so there's one path through the program. Oop, forgot to connect this. That we programmed in. Or did we? I'm sorry. Okay. I can save some time here by just stealing this. Instead of rebuilding everything. Control. Don't worry, you're not going to have to make these diagrams. This is just to illustrate how complicated things can be once you introduce selection structures. There are other ways to make it less complicated, but we'll get to those. Okay, so actually we didn't need this. We need this to connect there, this to connect here. I might just let you guys try to imagine the rest because I'm running out of time here. Okay. Oh, so this would be my hexagon area right here. Okay, boop. It doesn't automatically connect this. I'll have to manually. There we go. If you connect it, you know, together, it'll adjust automatically, which is really nice on this software. You can also use PowerPoint or Word for diagrams, but as far as I know, they don't allow you to connect different nodes together and maintain those connections as you move them around. So if you're in my database class or plan to take it, this is an extremely useful tool. So here, if they say what happens again if they say they aren't from Lakeland? Right now we just have to say nothing. So let's see now, because now we've determined, oh no, you know, we can get to a point in our program where nothing happens, and that's not good. So let's just add a quick thing in here. So if I want to put a message that'll print out if someone has lived in Mattoon but not attended Lakeland College, where does that go in this mess, right? Well, you can kind of follow the diagram down. So we need to go after we ask if they live in Mattoon, and we need to look at the else statement of checking whether or not they've gone to Lakeland. So here we have you ever lived in Mattoon? So we're checking Mattoon residency here, Mattoon historical residency. If they say yes, this happens. But if they say no, whoops, I'm looking at the wrong one. Okay, right. If they've attended Lakeland College, then we ask if they're a teacher or student. If they have not attended Lakeland College, that's this one. Whoops. Okay. You can put in little comments here, because the variables I used here don't really explain what's happening. This could be, you know, Lakeland College answer or LLC answer. Then it would be easier to track in the code, or you can leave comments. But anyway, this is what happens if it's true. This one is what happens when it's false, and so there's nothing there. So once it hits that point, the program's done, because we have no other code after the final else statement. But we can put in I don't know you. And then fight with Replit to let it put one double quote in there. All right. So now, what is your name? Have you ever lived in Mattoon? Why, yes, I have. Have you attended Lakeland College? No, I haven't. I don't know you. Okay. So, okay. Oh, yes. Good question, Miles. I have... You know, it's a good question for this class. If not, I feel like, you know, based on the material we've gone over so far, we've skipped half of an entire chapter, and we skipped chapter 4 because honestly, there's just not much value in those unless you're going to take a test where you have to explain the definitions of programming concepts, which I'm not going to make you do. So let's see what the syllabus says here. I have a very clear idea of what I want to cover in this class, but I'm trying to align it with the material so that you guys have more resources. Whoops, I never changed my name on here, huh? Oh, good, I just hit it. All right. Oh, well, this isn't going to help. I'm going to look at the PowerPoints. I'll go over the topics. So chapter 5 was selection structures. Chapter 6 is... It's cool because every one of these new concepts increases your capabilities as a programmer to actually create a solution to a problem, right? When you could take input and just print it out, do a calculation and print it out, you could use a spreadsheet for that or just do it on a piece of paper. But once your program gets more complicated and solves more complicated problems, it'll actually be a benefit to have the knowledge. Like, I'm not sure if anyone's in my Python class in here. We basically cover almost the exact same topics. Some are different though. And by the end of that class, you would be able to read in files, manipulate them, and write out new files. So you could create like, data manipulation programs, file editing programs, data conversion programs. All right. Okay, so chapter 6 is repetition structures. That's another useful tool. That's like loops. So you can make your code repeat. Saves you a lot of typing. All right, chapter 7. I don't know why this is taking so long to load. Too long. I think the PowerPoint reader in Canvas isn't the best. Okay, it's just faster to download it and open it than it is to load in this app. Oh, thank you. And I waited all that time for nothing. All right. Logical operators and truth tables. So this makes if statements more powerful and selection statements. That'll be good to know. Probably won't take us that long to go through, honestly. But we only got 2. If we do get through all of these chapters before the semester is over, I have plenty of material that's much more interesting than this that we can cover. Okay, modules. This is pretty much what I was talking about in separating your code into different responsibilities. So there's not much to do in that one either. And ooh, arrays. There we go. Okay. And then, so those, again, each of these just gives you so many more options in what you can build. I didn't see functions mentioned. We're definitely going to do that. And then, really what you're asking, Miles, is pretty, there's no reason I couldn't just show it next time in class. So and then people could have the option of using that or continuing to use it, the prompt. So remind me next time, and I'll do that in the demo, so you guys can create something that's looks and works a little bit better. Okay. In the meantime, let's see. Well, I guess you do need to understand functions for this to work, but I can give a very basic explanation of that. That would just get you going for this, and then it would be really good, just, you know, heads up for something we're going to talk about later. But okay, anyway, thank you for attending the class, and I will see you again next Monday on here anyway. If you need help, remember you can email me or schedule a Zoom meeting, and have a good day.